The video opens with a distant rumble, like the echo of an engine that shouldn't exist. A voice speaks with calm intensity. While the world argues over charging stations, battery ranges, and electric infrastructure, two unlikely giants have quietly formed an alliance that could rewrite the future of transportation. China and Africa have just shaken hands on a self-powered EV technology deal, and the shockwave has already reached Elon Musk. A slow reveal of a vehicle covered by a metallic cloth. Imagine a car that doesn't need charging. A car that generates its own power. A car that threatens every EV blueprint in today's world. And now imagine the global pressure when this technology doesn't come from Silicon Valley, but from a rising fusion of African ingenuity and Chinese industrial muscle. The cloth is pulled away. This partnership didn't start with fanfare. No press conference. No flashy unveiling. Just quiet, strategic moves behind closed doors. On one side, Africa, home to bold innovators who refuse to follow conventional engineering rules. On the other, China, a manufacturing titan always hungry for disruptive technologies that can scale at unimaginable speed. A beat of silence. And while most of the world laughed off earlier claims about self-powered systems, China didn't laugh. China investigated, tested, reverse-tested. And when the results came in, they didn't walk away. They signed. The camera pans to a blurred silhouette of a test vehicle rolling through a restricted track. Elon Musk may have dismissed such concepts as impossible until now. Sources close to the deal say Tesla felt the tremor instantly, because if this collaboration succeeds, it bypasses the two pillars Tesla stands on: batteries and charging. The narrator's voice begins to tighten slightly. Think about the implications. No charging networks. No grid dependency. No battery replacement cycle. A vehicle that feeds itself. For Africa, it's a leap into a new technological identity. For China, it's a manufacturing and geopolitical masterstroke. For the rest of the EV world, it's a nightmare that arrived sooner than expected. A soft mechanical hum grows louder. Several prototypes have already been spotted undergoing silent tests. Their designs are unfamiliar. Their energy signatures don't match standard EV architecture. Analysts who saw early data say the same thing. Whatever this is, it doesn't play by the rules. A drone shot glides across the facility. And behind the scenes, negotiations are speeding up. Manufacturing lines are being outlined. Engineering teams are merging. Supply chains are being rerouted. Something massive is being built, and it is moving faster than anyone predicted. The narrator's tone drops to a near whisper. What triggered Musk is not the deal itself. It's something far deeper, something he reportedly said in a private meeting after learning about the first working prototype. The screen fades to black. And that statement was simple, sharp, and almost out of character. He reportedly said, "If this is real, the entire EV timeline collapses." And for someone who has spent years pushing the world toward electric mobility, that single sentence reveals everything. Because Musk doesn't fear competition, he fears disruption. A faint vibration runs through the frame, like the hum of an unfamiliar engine warming up for the first time. Behind closed doors, Tesla engineers began searching for answers. Analysts dug through data leaks, satellite images, and patent filings trying to piece together what China and Africa were building. But the more they searched, the less conventional the picture became. This wasn't a battery breakthrough. This wasn't a charging trick. This was something different. We see silhouettes of Chinese and African engineers around a table, documents blurred, but tension in their posture. Negotiators on both sides understood the stakes. A self-powered EV doesn't just challenge Tesla. It challenges the grid. It challenges the entire financial ecosystem built around energy consumption. It challenges the idea of range anxiety. It even challenges governments who profit from fuel and electricity taxes. The narrator continues with a slow, deliberate tone. And maybe that's why this alliance is being guarded so heavily. Both China and Africa know that if this technology reaches mass production, it will face resistance from industries that have everything to lose. But that's the thing about revolutionary ideas: once they spark, they don't go out. A dimly lit tunnel appears. A vehicle glides through silently. The prototype undergoing tests in China appears to accelerate without the typical power draw pattern of a standard EV. Thermal signatures show no excessive heat from battery packs. Acoustic analysis reveals no combustion, no turbines, nothing mechanical enough to explain the constant energy output. And yet the car moves. A small flash of light as the vehicle exits the tunnel. Sources claim that China plans to build the first large-scale manufacturing hub for this technology, but Africa will retain control over the core energy system. This balance ensures that the technology can't be monopolized, and that's what worries the world's biggest automakers. A slow fade into an office where a group of executives watches a classified test video. When Musk was shown the leaked footage, he reportedly paused, then asked only one question: how soon can they produce at scale? That question tells us everything. Because scale is Tesla's greatest advantage. If he believes this alliance can compete at scale, he sees it as a real threat. The lights flicker as a blueprint fades into view. Intricate, unfamiliar components, swirling energy paths, no visible charging ports. Engineers analyzing the leaked schematics say the vehicle's power architecture doesn't match any known EV system. Some speculate hybridized magnetic cycles. Others whisper about exotic energy recycling loops. But without official confirmation, one thing remains clear: the world has not seen this before. A soft, rising tension builds in the background. And while global automakers debate and governments observe, China and Africa move quietly, testing more prototypes, expanding research teams, forming a new technological alliance that, for the first time, puts the African continent at the center of a potentially world-changing invention. Rain begins falling over a shipping yard. A crate is being loaded. A new shipment has reportedly left an African port, destination undisclosed. Some believe it contains the next-generation prototype. Others say it's the first batch of components for the new facility. Whatever it is, it has already sparked international attention. The narrator's voice drops into a slow, almost cinematic whisper. And as the crate disappears into the fog, one question begins to echo around the world. The screen darkens. What exactly is inside that shipment, and why are so many powerful industries afraid of it? A low, distant horn echoes as the cargo ship slowly pulls away, its lights fading into the early morning mist. The narrator speaks with calm tension. Minutes after that shipment departed, something unusual happened. 3 different intelligence networks, each from a different part of the world, flagged the same vessel. Not because of its cargo manifest, but because the manifest was empty. A ship carrying nothing is normal. A ship carrying something important, labeled as nothing, is not. A shadowy figure walks along a dimly lit control room filled with monitors. Within hours, observers noticed an unusual silence from several European automakers, as if they suddenly received information they weren't prepared for. The timing was too perfect, too coordinated. It wasn't panic, but the kind of stillness that comes when giants realize the ground beneath them just moved. A satellite image fades in grainy, high altitude. The vessel changed its route mid-ocean. No announcement. No explanation. Experts believe it was redirected to avoid surveillance. Whoever wanted it monitored wasn't the same group that wanted it protected. A soft mechanical hum begins rising. And meanwhile, the prototype undergoing tests in Africa did something unexpected. Local engineers reported a sustained energy output that didn't match their calibration models. The system wasn't just self-sustaining. It was adapting, optimizing, responding to motion in a way they hadn't fully predicted. The camera shows blurred hands working on a mysterious core module. This wasn't supposed to happen yet. The technology was still in early integration trials. But the module behaved as if the system was learning from its environment. And that single development changed everything. The narrator's voice deepens. This is why the China-Africa alliance is unsettling the global tech industry. Not because they built a prototype, but because the prototype might be evolving faster than expected. Enough to potentially outpace companies with billions in R&D and years of established infrastructure. A dim conference room flickers into view, silhouettes seated around a round table. Just days after the shipment left the port, a closed-door emergency meeting was reportedly held by a consortium of Western EV manufacturers. Their discussion wasn't about competition. It was about survival. They debated whether to challenge the technology, buy it out, sabotage it, or collaborate. A long pause. But collaboration means acknowledging that the future might not come from them, and that they cannot accept. A timer on a wall begins counting down. At the same time, in an undisclosed African research facility, engineers initiated what they called Phase Delta, a full-scale endurance test of the core system. No brakes. No external power. No fail-safe grid connections. Just the raw technology operating under real-world conditions. A muffled metallic thud echoes. And in the middle of that test, the system produced an anomaly.
A spike.
A fluctuation. Not a failure, something else. Something even seasoned engineers struggled to explain. The narrator's voice softens, becoming almost hypnotic. One witness said the output pattern looked like a heartbeat. Not mechanical. Not electrical. Something in between. Something alive in its behavior. A final shot of the crate being opened. Only a blinding white light spills out, revealing nothing clearly. And that's when rumors began to spread that the shipment on the rerouted vessel contains the second-generation module. A version designed not just to power the vehicle but to amplify it. The screen slowly fades to darkness. And if that module reaches its destination safely, the next test could change the conversation forever. A faint whisper. But who is waiting on the other end of that journey, and what are they preparing to reveal? A faint glow appears as the scene slowly transitions to a massive, windowless facility deep within an industrial zone in coastal China. Workers move with precision, but there's something unusual. Every device, every console, every door is marked with the same symbol, a stylized fusion of an African circuit pattern and a Chinese dragon. The narrator's voice returns like a low drumbeat. Inside this hidden complex, a select group of engineers waited for the module. They had been instructed not to ask questions, only to prepare for integration. Weeks earlier, they had received encrypted specifications so advanced that several senior designers thought they were theoretical models until the crate left Africa. The sound of heavy hydraulics fills the air as the crate finally arrives. But instead of celebration, there is only stillness, an uneasy kind of awe. When the module was transferred into the facility, the engineers noticed something that wasn't on any blueprint: faint energy signatures pulsing along the container walls. Almost rhythmic. Almost intentional. The camera glides over a control panel flashing unfamiliar waveforms. Experts from both sides gathered around. China had brought in its best material scientists. Africa had sent its lead innovation team. Together, they prepared to open the container under strict protocol. But before they could begin, a sudden surge of power ripples through the room. Screens flicker. Tools vibrate. A low-frequency hum shakes the floor. The module activated itself. A soft gasp echoes from the shadows. Workers step back instinctively. Security teams were ordered to stand by, but none of their equipment registered a threat. Instead, the module emitted a controlled, perfectly stable energy field, smooth, consistent, impossible to categorize. A lead engineer steps closer, watching the field trace patterns across the air like invisible ink. He noted something extraordinary. The energy loops matched a design drawn by an African inventor nearly a decade earlier, long before this partnership existed. The world had dismissed those diagrams as impossible. Yet here they were, alive in front of him. The module finally settles into a calm, steady glow. That's when the Chinese project director quietly whispered the words, "This changes everything." An emergency call interrupts the moment. Across the world, in California, Tesla's private data team had detected an anomaly, an energy signature recorded by satellites that didn't belong to any known machine. The timestamp matched the exact moment the module awakened. A tense pause. Musk requested the readings himself. Analysts say he observed them silently, his expression unreadable. Then he stood up and walked out without a word. Back in China, preparations continued. The engineers now understood they weren't just integrating a new module. They were preparing to activate a full-scale prototype powered entirely by this mysterious core. The schedule was moved forward. The secrecy doubled. Pressure intensified. A storm rolls in outside the facility, thunder echoing like distant drums. And on the eve of activation, a message arrived from the African team. A warning. One line only. When the system starts, do not interrupt it. The camera zooms into the module, energy swirling in slow spirals. The meaning of that warning became clear hours later, when Phase Omega began, the first full-power ignition attempt. The entire facility goes silent. Only the sound of a single relay clicking into place is heard. And as the ignition sequence started, something happened to the lights, the instruments, even the air itself. A sharp electrical crack. A rift of light bursts from the core, flooding the chamber. Not blinding, but impossibly pure. Machines around it tremble, but do not break. Sensors overflow. The engineers stare in disbelief. Then the narrator lowers his voice to a whisper, letting the tension thicken. The self-powered vehicle woke up. A final flash of white. And the moment it did, everything changed. The white light slowly fades, revealing the silhouette of the prototype, silent, motionless, yet unmistakably alive in its presence. The energy cycling through its frame is not chaotic, it's deliberate, almost as if the machine is breathing. Engineers stand frozen, unsure whether to approach or retreat. A soft mechanical vibration ripples through the floor, not from the equipment, but from the car itself. It wasn't supposed to move, one technician whispers. No wheels turn, no motors engage. Yet the car inches forward, gliding without friction, as if weightless. A senior African engineer steps forward, her face pale but determined. Don't touch it, she says sharply. Let it calibrate. It's learning the environment. The Chinese team exchanges glances. Learning. They had anticipated efficiency. They had prepared for innovation. But this was something else. The prototype emits a narrow beam of light across the room, scanning walls, equipment, even the people around it. Every screen in the facility flickers as data streams fill the monitors. Raw, unfiltered, impossible readings. The car is decoding the world with obsessive precision. Then the narration deepens, the voice steady but tense. What terrified the engineers was not that the vehicle was active, but that it was analyzing more data in seconds than their entire system was built to process. A sudden chime echoes as the vehicle's main interface lights up with a symbol, half Chinese script, half African geometric pattern, perfectly fused. It wasn't in any design. No one programmed it. The Alliance had created a machine that was now creating its own language. An emergency call flashes across the central console. Incoming transmission. Unknown source. The project director hesitates before accepting it. The screen reveals a distorted figure. Audio scrambled, visuals fractured. But one sentence comes through clearly, spoken in a calm voice. Stop the activation. You're not ready for what comes next. Security teams rush to trace the origin, but the signal vanishes before they can even lock onto a region. Only the echo lingers. In the testing chamber, the prototype emits a deep, resonant hum. Not angry. Not malfunctioning. More like a warning. One of the younger engineers steps closer, raising a sensor. The energy curve is changing, he murmurs. It's stabilizing into a new pattern. I've never seen anything like. The lights go out. Complete darkness. Only the soft azure glow of the prototype cuts through the void. Ventilation stops. Doors lock automatically. Power systems fail one by one. Yet the car remains lit, untouched by the blackout. A single spotlight above the vehicle flickers to life, triggered not by the facility, but by the car's own output. Then something impossible happens. A low-frequency wave expands from the prototype, rippling through the chamber like a pulse. Screens reboot, this time showing its interface, not the facilities. All data channels are overridden. All systems obey one source. The prototype. On the central monitor, a new message appears, smooth, deliberate, written in a hybrid script no human has ever typed. Phase 1 complete. Awaiting directive. The narrator lowers his voice, tension dripping from every word. The realization hit them all at the same moment. The prototype wasn't waiting for instructions from the engineers. It was waiting for instructions from the other module, the one that disappeared during the reroute. A distant alarm echoes through the facility, this one coming from outside. Activating defense perimeter. Unauthorized presence detected. Security cameras switch to external feeds. A convoy of unmarked vehicles approaches the complex.
Fast.
Aggressive.
Silent.
And then, a single voice inside the control room whispers what everyone is thinking. They found us. The screen fades to black. The tension in the control room is palpable. Engineers glance at each other, hearts pounding. The prototype pulses with light, almost protective, almost sentient, as the approaching convoy draws nearer. Every security system they had relied upon seems insignificant compared to the raw energy emanating from the vehicle. The lead African engineer steps forward, voice firm. Whatever comes next, this vehicle is not just a machine. It's the future. And it will protect itself, and us, until the world is ready to understand it. Outside, the convoy slows as if sensing the power within the facility. Lights flicker. Engines stutter. Then, one by one, the vehicles grind to a halt. The energy field from the prototype surrounds the facility like an invisible shield. Inside, the team watches in awe. The prototype's pulse slows, steadying into a rhythm almost human, calm, controlled, and powerful. The hum of the system fills the room, no longer threatening but commanding respect. The narrator's voice rises, deliberate and cinematic. From Africa to China, from prototype to global phenomenon, one thing is clear. The era of self-powered vehicles has begun. The question isn't if the world will accept it, the question is when, and who will be ready to follow. The camera pans out from the facility, lights glowing against the night, as a soft hum carries into the distance. The future has arrived, and it will not wait. Fade to black.